Hello everyone, today I'll explain linear search and big O in Python. So let's imagine that we have a list of numbers and we need to find the index of number, for example, 8. So what's an index if you don't know? An index is a positive integer which describes where in our array element is located. So for example, element 1 and indexes in Python starts with 0. Element 1 is located on the index 0. Element 2 is located on the index 1. Element 3 in the index 2 and so on. So element 8 in our array is located on the index, I think 4. 0, 1, 2, 3, 4. Yeah, and if we need to find that index, we can use linear search. Linear search, I'll call create new function and I'll pass in array and search. Array and key. So array, it's an array in which we'll look for our key, and key, it's an object which index we will return. That's easy. For I in range, len, and I'll pass in array. So if you don't know, range is a function which will create a list of numbers starting with 0 in our case and ending with len of array. And the len of array, it's a function which will return the length of our array. So I can print variable I and call linear search and pass in a array, and for key none, because we don't use it yet. Okay, I'll run my code, and as you can see, first of all 0, then 1, and so on. So we can use variable I as a representation of our index. So I will create if array on the index I equals key. So if array on the specific index, so element of array on the specific index equals to our key, what we'll do? We will simply return our I variable, because as I said, I in our case is a representation of our index. And for example, let's look for number 3 in our array A, and I will print linear search just to show you the result. Let's start our program. It says 2, so index 2. As I said, indexes start with 0, and for in our array A, 0, 1, 2. Okay, let's look for number 0. It's the last number. It says index 6, and everything works fine. But what if we look for number, for example, 100? We don't have 100 in our list, and let's look. It says none, because by default functions return none, and if our condition doesn't work, we won't return our I at all. So we don't have 100 in our array, and many functions in that case, if they don't find a number, they return -1, because there is no negative index, and -1 can be represented as none in many languages. So just to show you, I will return -1, and if I run, -1 is returned. Okay, and one issue in our code is duplicates. It's not an issue, it's just okay, it may be an issue. For example, we have a duplicate of 1 in our array with index 0 and with index 0, 1, 2, 3. With index 3, it will always return the first element of our, so 0, 0, 0. It will never return the last element of our array. And you can upgrade your implementation as you wish, but for now I won't do it because there is no point, I think. Okay, so now let's have a talk about big O. So big O, it's a concept which describes how many steps, in the worst case, our algorithm will do before completing itself. So in the worst case of linear search, it will take O by n steps. What does that mean? We ran through all of our elements, and if we look for element 0 in our array, it will take n elements. So n, it's, I can write here, n, it's a length of our array. So we'll run through all of our elements in array, and that's the worst case scenario in our algorithm. And that's basically all. So I can write O and N. It's linear search. So in the future, we'll write algorithms which are faster than linear search, and binary search is one of them. And for now, we have linear search which works correctly and looks for index of element in our array, and it has speed of O, O, N. And that's all. Good luck.